Hello guys, welcome you all to Debugging Doubts. Today let us understand about the Peterson solution. So why do we need this? Whenever there may be some part of the code where one variable is shared with many processes. Okay, consider processes P1, P2, P3, something. So if P1 process wants to write a variable, let's suppose take x, okay, x is equal to 10, and it will assign x is equal to 10, then it will print the variable and then complete its execution. Now P2 will come and its process is to make x is equal to 20 and it will come out of the critical section. Suppose both of the processes are executed concurrently, then P1 will assign it x is equal to 10, but P2 will suddenly interrupt and make x equal to 20, and P1 once again will print the value as 20 only. So this is somewhere the wrong variables are being printed, right? So in order to make the process like P1, P2 something, to ensure that only one process will use the critical section, all the code segments which uses the shared variable and are harmful if two processes execute concurrently are kept in the critical section. You can see in the diagram, it will be kept in the critical section and the above rules. So this whole program is the Peterson solution to make ensure that only one process will act on the critical section, and if any other process try to interrupt it, then it is not possible. So it the other process should wait till the one process gets completed. Now let us understand the visualization. Then you will get a clear knowledge of what we are doing. Now you can see Peterson solution. Okay. So flag is a Boolean array. So you can see flag of I is false and flag of j is false. And turn is a variable, shared variable. See, all these data are shared with both the process. So there are two processes, process I and process j. Now, whenever process I wants to execute the critical section, the code segment, okay. So what it does, first has the algorithm said, first flag of I will be set to true. Okay. So the process will say, I'm ready to execute. Okay. See, process will say, I'm ready to execute. And then it will set the turn is equal to J, means it will set the turn for the J. So it will try to say that if process Pj wants to execute, you can execute. So see, you can see it is set to J, turn is set to J. You can see J is 1. Now what it does is flag of J is checked because it will check whether flag of J is true, like whether it is ready to execute. So you can see it is false. And whenever there is a false in and condition, so all the complete this thing is false, right? So it will terminate the while block. You can see the semicolon, right? And then it will enter into the critical section. Now after completing the critical section, so it will come out and set flag of I is equal to false, means I have executed this process. Then it will go to remainder section and execute its own task. Now let us take another scenario. Now flag of I is true, so turn of j is set to other process, and it will be checking now for the while condition. Till then pj also will do the same thing. Flag of j is equal to true, then turn is equal to I, means it will set the turn for the process I. See, now it is set, turn is set to 0, means I is equal to 0, right? So now what it does, which process do you think will execute? Now you can clearly see that whenever the flag of I is true, yeah, both the case, the both the while condition will be set to true. But you can see now whose turn is mentioned here, turn of 0, means I. So now process I will be executed and not process J. So if I try to execute process J, see, it's saying it's waiting. Why? Because turn is equal to I, it's checking. Okay. The value of turn is 0, means I. So I is equal to I. It is true. And flag of I, that is also true. So the while loop will run for infinite number of times because you can see the semicolon. So it will be running infinite number of times. But what happens here? So turn is equal to j. It will check whether other process is working or not. But you can see the turn is given for I, that is 0. So I not is equal to j. It will tell false, and it will enter into critical section. And after entering this thing, flag of I is set to false. That is, it has executed. The process I has executed the this thing critical section, and it will set to false. Now what happens? Now the while loop in the process J will check. Flag of I is false, right? So it will directly tell it is false, and it can enter now because while loop breaks here. So it will enter into critical section, then execute the commands, and finally it will say flag of J is false, that is process PJ has been completed. Now let us take another scenario. Okay, now let us understand in the story form. Now flag of I is equal to true and flag of j is equal to true means process I will say, yeah, I want to execute. So it will say true. Okay. Now process j will say, I also want to execute. So it will set to true. Now what happens? Turn is equal to j. So the process pi says, I want to execute. But let first pj will complete execution. So it will set to 1. So j is 1, right? Now what process J says, I want to execute, but let process Pi execute first. So it will set the value to 0. Now whose value is considered in the turn? So turn value can't be both 0 and 1. So whichever the value will be in the last is considered. Now the turn value is 0, right? So process I will be executing. But let's check what process J is thinking. Okay. So it will check. While flag of J is equal to I means whether the flag of I is true or not, means whether he wants to execute or not. Yeah, he wants to execute. And even the process I will think whether process J wants to execute or not. So it will also execute. Now there should be some condition, right? So both of them want to execute, both of them knows there should be some condition that okay, only he has to execute. So that comes the turn. So turn will say whether process j is executing or not, and you can see turn is 0 instead of 1, that is j. So it will say no, false. Then in the process j you can see turn is equal to I, means here it is 0. Yeah, it is true. So it will understand that now the turn is of the other process, and both of them are condition true, then it will keep on running infinite number of times. But here turn of j will directly get false, and it will enter into critical section, and the process will be executing critical section, and finally it will say I have executed, and set it to false. And then you can see flag of j, it will check whether it is executing or not, but here you can see it will be false, so you come out the remainder section. So this algorithm is very important to understand the basic knowledge of how the synchronization works. So here we can see the solution for the any kind of critical section is that the three conditions should be satisfied. That is mutual exclusion. So whenever one process is executing, you can clearly see that other process cannot execute. So this satisfied. Next thing is progress. So whenever if one process is ready, so it will directly enter into a critical section, and it will execute. And third is bounded waiting. So this also condition satisfied, and hence this solution is valid. So this was all for today, and it might be some little tricky for you all to understand if you are watching this for first time. But you need some practice. You tried analyzing, you try the visualization too, and this will help you to understand more better and clearer. Try to analyze the algorithm first. So this was all for today, and if you like my video, please like it, share it, and subscribe it. And thank you guys for watching.